Now we have all used escalator at one point in time or the other, maybe in shopping malls or multiplexes and all. Obviously when we go up and down the escalator, we never worry about how much time we will take. In fact, we are always happy to see an escalator compared to the staircase. But in time, speed and distance, because we deal with mundane things in life, we try to find some mathematical joy in everything that we do in daily life. Therefore, we'll focus on escalator. Now, escalator is slightly, you may call it interesting or weird concept. That there are people who walk on escalator. I know, but I walk with the escalator. There are smart Alex who actually walk against the escalator also. So in our concept, we will use the entire universal, the entire mankind. People who stay on the escalator, they let escalator do the job. People like me who are always a little eager to contribute, so we walk with the escalator. And there are people, adventurous people, who find adventure in the dangerous act of actually walking against the escalator. So we'll use all these concepts to frame our question and understand this whole thing. But first let's understand some very basic concept. So understand, we are using escalator as a time, speed and distance question. So let's convert everything into concepts that we associate with time, speed and distance, which is distance. So in distance in this case is fixed. Escalator is nothing but a series of steps. If escalator stops, if someone pushes the red button, this is nothing but a series of steps which we use in our daily life. So escalator is nothing but series of steps. And though it's very obvious, but some of us, we fail to see the obvious. We have to understand the distance in this case is fixed from top to bottom. Whichever way the escalator is going, it does not matter. The distance is fixed, those series of steps. Like in clocks, we measure the distance in degrees. Here in escalator, we measure the distance in terms of steps. Because obviously, it's such a difficult terrain. It's difficult to measure it in terms of degrees or meters or kilometers or miles. So we measure in terms of number of steps you need to take to cover the distance. Okay, which means that we assume that each step is uniform, which is generally the case also. Now speed here is the speed of the escalator, because it's a moving staircase, so it's the speed of the escalator plus if you contribute anything. So if you move along with the escalator, you help it out. Like boats and streams, when you're going downstream, if you put a log will move at the speed of the stream, but if you are rowing your boat, then obviously you will move faster, because stream is aiding you plus you are putting in your effort. So if you walk down the escalator and a moving down escalator, then obviously you will move faster. But suppose you just put a shopping bag here, so that your wife can collect it at the end of the escalator. Most of you are students, so we will substitute wife with whatever you feel comfortable with. But if you put a shopping bag here, then the shopping bag obviously will not make any movement unless and it's a horror movie. So shopping bag moves in its own speed, at the speed of the escalator, and will be collected by your concerned person at the end of the moving escalator, right? So then there is no effort from the part of the person or the bag involved here to increase the speed. It moves at the speed of the escalator. Okay. Now sometimes, as I told you, the people who seek adventure, they move against the escalator, whichever direction it is moving in. For example, if the escalator is going down, I'm sure there are people who find a lot of joy in moving against the escalator, going up on this escalator. Though there may be a ready escalator which is going in the direction they want to go, right next to it. But somehow, this is their sense of adventure. These are the people who provide joy to us in life. Similarly, if this is the moving escalator which goes up, you will always find people who stand right on top of it. They will see that it goes up and then they will start walking down. They contribute a lot towards development of maths, because we can frame a lot of questions based on their traits, right? We will come to these questions, okay? So this is the basic idea. The only thing you have to understand is that when you go against the escalator, like in boats and streams, your speed minus escalator speed. Again, if you go against the escalator, when escalator is going up, you go down. So your speed minus the speed of the escalator. Couple of simple questions and we will understand. For example, say we say your speed of the person, SP speed of the person, SE speed of the escalator. See, your speed is 2 steps per second, SPS steps per second. Okay, so you take 2 steps every second. Escalator works on your behalf, so it takes 3 steps every second, right? Now say you say this is me, which means a normal person, so we move along with the escalator. Last thing I want in life is adventure. So I move along with the escalator. I like people to do my things, do work for me. So together we cover 5 steps per second, right? Now it's given that time taken for you to go in that escalator is 4 seconds. So I take 5 steps every second along with the escalator, my dear friend, and in 4 seconds I manage to bridge that gap. Which means, how many steps do I take along with the escalator? 5 steps every second into 4. So all in all we take 20 steps. We take 20 steps because the gap is 20 steps, because we are supposed to take 20 steps. That is the only way I can cover the gap and go to the other end, right? So either I take or escalator takes on my behalf. So the gap is 20 steps, right? We understand this? Okay. Now say the question goes like this: when you are going with the escalator, you take 10 steps. Also understand this. Now when you go with the escalator, escalator does work on your behalf, right? Which means you will take less steps than when you are going against the escalator. Because when you are going against the escalator, you are trying to override the escalator, overwhelm the escalator. Say I will be faster than the escalator. But when you go with the escalator, you let escalator do a lot of work for you. So when you go with the escalator, you will take less steps compared to when you go against the escalator. Okay? So when you go with the escalator, you take 10 steps. When you go against the escalator, you take 40 steps. So how many steps are there in the escalator? Now prima facie, this question looks a little tough. But if we understand the simple concept of time, speed and distance, this will be easy. Now just understand this. Escalator works in tandem with you. Escalator is not working in isolation. The time frame, the context, the whole environment is same. So if I take 10 steps in one case, I take 40 steps in one case, right? My speed is same. So the time taken by me to take 10 steps and time taken by me to take 40 steps, what will be the relationship? I am the same person, right? My speed is constant, uniform. So the time taken by me to take 40 steps will be 4 times the time taken by me to take 10 steps. Right or not? Huh? So we take case 1 and case 2, say. Case 1 and case 2. I take 10 steps, I take 40 steps. My simple submission to you is that the time ratio, if this is T, this will be 4. Okay. Now extending that concept, escalator is working in unison along with me, right? Which means in the same time frame, if escalator takes E steps here, it will take 4E steps here, right? Let's take 5 seconds to absorb this whole concept. That I take 10 steps, I take 40 steps. Forget going with and going against. Just take them as two independent cases. Obviously, because I am the same person, moving at the same constant speed, the time taken by me to take 40 steps will be 4 times the time taken by me to take 10 steps. So T and 4T. But that will be true for the escalator also, because escalator is almost like my friend moving along with me. So whatever distance escalator covered in this case will be 4 times the distance that it covers in this case. Same idea, right? But the distance that me and escalator together or we working against each other cover, that distance is constant, na? Escalator, that distance, series of steps. So distance is constant. That is the whole idea. Distance is constant. First case, I move with the escalator. So together we happily cover 10 plus E steps. So the distance is same. So next case, we fight with each other. I go against the escalator, I win, alright, but it takes a lot of work. How many steps do we cover? Me minus escalator. But the distance is same. Now, can we easily solve this and get an answer? But we can. So escalator, if you solve this, you will get escalator is equal to 6. So escalator takes 6 steps. When I take 10 steps. Escalator takes 24 steps, 4 into 6, when I take 40 steps. So number of steps in the ladder, in the moving escalator is 10 plus 6, 16, or 40 minus 24, 16. So the answer is 16. Okay, right? Now let's come to third question. Similar type of question is here, instead of number of steps, we have put the time. So when I go with the escalator, I take 15 seconds, obviously, because someone is aiding me, abetting me. When I go against the escalator, I take 35 seconds, because someone is working against me, right? Very simple. So the question then is that how much time will I take if the escalator is not moving, stationary, constant, malfunctioning? If I just walk down the steps, then how much time will I take? Okay. Now, when I go with the escalator, the relative speed is my speed, speed of the person, plus speed of the escalator. When I go against the escalator, my speed must overwhelm the escalator speed. So it is speed of the person minus speed of the escalator, right? Now speed ratio will be inverse of the time ratio. So my speed with escalator, my speed against escalator is 35 by 50 or 7:3. Now using simple ratio concept, I can find the ratio of my speed and escalator speed, which comes as 5 by 2. Okay. So if escalator is 2, I am 5. Again using the simple ratio concept, if the ratio of my and escalator speed is 5 by 2, then ratio of my speed and our combined speed me and escalator put together will be 5 by 5 plus 2. 5 by 5 plus 2, which is 5 by 7. So if my speed is 5, escalator is 2, so our combined speed is 7. Very simple. So the ratio of the time between my speed and our combined speed will be inverse of 5 by 7. Our ratio of speed is 5 by 7, so ratio of time will be inverse of 5 by 7. So time taken by me alone, time taken when I work with escalator, this ratio will be 7 by 7. Okay. Now we know that time taken when I move with the escalator is 15 seconds. This was the information given by the question itself. So this 5 is actually 15 seconds. So I can easily find the time that I will take alone, which is 7 by 5 into 15, which is 21 seconds. Time that I will take alone means that escalator is not working. Escalator is constant, stationary, immobile. That is what it means. I will take alone to cover that distance. So escalator is neither moving with me nor against me. Okay. So this is a very simple concept. People do get confused in escalator, but if you just take some time to understand the basic idea here, distance constant measured in number of steps, you and escalator work together at the same time, either together or against each other. And your work, your effort is measured in terms of number of steps. That is all that there is to it. Okay. Thank you.